Welcome back to History for Sleep, where we drift through the deep past one story at a time. Tonight, we're going on a slow, soothing journey into one of the most profound mysteries of human evolution. For 300,000 years, while our ancestors were learning to master fire and shape the first tools, another species of human relative walked this earth alongside us. They weren't quite like us, yet they weren't entirely different either. They existed in the shadows of our own story, leaving behind whispers in stone that we're only now beginning to hear. As always, I hope this video helps you drift off gently, or at least helps you put your worries into perspective by zooming out a few 100,000 years. Of course, there's a small risk that it might be too interesting and keep you awake. But if that happens, well, at least you'll have learned something fascinating along the way. Before we float off into the past together, I'd love it if you gave this video a like and maybe even subscribed if you haven't already. It really helps this sleepy little channel grow. I'd also love to know where you're watching from and what time it is for you right now. Let me know in the comments. It's always such a joy to see our sleepy history community scattered gently across the globe. Now, settle in. Get comfortable. You don't need to remember any of this. You don't need to take notes or stay alert. Just let the words wash over you like whispers on the wind. And as we begin this gentle voyage into the vast unknown, remember this video is for educational and relaxation purposes only, and is not intended as medical advice. Ready? Let's begin. Our story doesn't begin with a person, or even with a discovery. It begins with a place that has existed in darkness for millions of years, keeping its secrets in the most profound silence you can imagine. Picture, if you will, the landscape of South Africa's cradle of humankind, about 50 kilometers northwest of Johannesburg. This is a land of rolling grasslands and scattered trees, where the earth itself seems ancient and weathered, carved by countless millennia of wind and rain. The surface looks unremarkable, almost ordinary, dotted with the occasional rocky outcrop and patches of thorny vegetation that whisper in the breeze. But beneath this peaceful surface lies another world entirely, a world of limestone caves that twist and branch through the earth like the roots of some impossibly ancient tree. These caves were formed over millions of years, carved by water that seeped through cracks in the rock, dissolving the limestone grain by grain, drop by drop, in a process so slow that human lifespans are meaningless against its scale. The water carried away the dissolved rock, leaving behind voids that grew larger with each passing millennium, creating chambers and passages that no living thing had seen for ages beyond counting. Among these cave systems is one known as Rising Star. From the surface, its entrance is nothing more than a modest opening in the dolomite rock, barely noticeable among the scattered boulders and dry grass. Local cavers had known about it for years, but it held no particular significance. It was just another cave in a region full of caves, another dark space beneath the earth. But Rising Star was keeping a secret, one that would fundamentally change our understanding of what it means to be human. The journey into Rising Star begins innocently enough. The entrance chamber is spacious, almost welcoming, with enough room to stand upright and move around comfortably. Natural light filters in from the opening above, creating patterns of shadow and illumination on the rough limestone walls. The air here still carries hints of the outside world, the faint scent of grass and earth, the occasional movement of air that suggests connection to the surface. But as you move deeper, following the path that generations of cavers have taken, the cave begins to change. The passages narrow. The ceiling drops lower, forcing you to crouch, then crawl. The walls press closer, and the comfortable spaciousness of the entrance chamber becomes a memory. The light from the surface fades to nothing, and you enter a darkness so complete that your eyes strain uselessly, searching for even the faintest glimmer. This is not the darkness of night, where stars provide points of reference and the moon casts shadows. This is absolute darkness, the kind that makes you question whether your eyes are open or closed? In this darkness, every sound becomes amplified. The scrape of clothing against rock echoes through the passages. Your breathing seems impossibly loud, each exhale bouncing off the walls and returning to you changed, distorted. The drip of water somewhere in the distance creates a rhythm that seems to mark time in this timeless place. And underneath it all is the silence, a silence so profound that you can hear your own heartbeat, the rush of blood through your veins, the small sounds of your body that are usually drowned out by the noise of the world above. The temperature drops as you descend. The warmth of the South African sun becomes a distant memory, replaced by the constant cool embrace of the earth. It's always about 15 degrees Celsius down here, winter and summer, day and night. Time loses meaning in this perpetual twilight zone. The rock around you is ancient beyond comprehension, formed in seas that existed before the dinosaurs, before complex life had even ventured onto land. You're surrounded by the compressed remains of countless tiny sea creatures that lived and died hundreds of millions of years ago. Their shells and skeletons transformed by pressure and time into the limestone through which you now crawl. As cavers pushed deeper into Rising Star over the years, they encountered passages that tested the limits of human exploration. One section, which would later become infamous, requires you to squeeze through an opening barely wider than a human torso. The rock presses against you from all sides, and for a moment, you experience what it might feel like to be swallowed by the earth itself. This is not a place for the claustrophobic. It's barely a place for anyone. The passage is so tight that many experienced cavers simply cannot fit through it, no matter how they contort their bodies. But for those who can make it through this squeeze, who can push past the primal fear of being trapped beneath thousands of tons of rock, the cave continues. It opens into another chamber, then narrows again, then opens once more, like the earth is breathing, expanding and contracting around you. Each chamber has its own character, its own particular arrangement of stalactites and stalagmites, its own patterns of flowstone where ancient water has deposited minerals in delicate frozen waterfalls of rock. Deeper still, the cave presents what cavers call the Superman crawl, a passage so narrow that you must extend one arm forward and one back, like Superman in flight, just to fit through. Your chest scrapes against the floor, your back against the ceiling. You move by inches, using your toes and fingertips to push and pull yourself forward. The rock is smooth here, polished by the countless small movements of water and time. It's almost organic in its curves, like being inside the fossilized intestine of some massive prehistoric creature. This is where most explorations of Rising Star ended. The cave was mapped, noted, and largely forgotten. It was challenging, yes, but not particularly remarkable in a region full of challenging caves. There were no spectacular formations to attract tourists, no vast chambers to inspire awe, just narrow passages and darkness, interesting to the dedicated caver but holding little appeal for anyone else. For years, decades even, Rising Star kept its secret, waiting in the darkness with a patience that only geological time can afford. The limestone of these caves has a particular quality that makes it ideal for preservation. When bones find their way into these spaces, whether carried by water, predators, or other means, they can become entombed in sediment that protects them from the usual processes of decay. The constant temperature and humidity create conditions where mineralization can occur, slowly replacing the organic material of bone with minerals from the surrounding rock. It's a process that takes thousands of years, but in these caves, thousands of years pass like days in the world above. Throughout the cradle of humankind, these limestone caves have yielded treasure after treasure of human evolution. The famous fossils of Australopithecus africanus, our ancient ancestor who walked upright but still retained ape-like features, were found in caves not far from Rising Star. The skull of Mrs. Please, one of the most complete early hominin fossils ever discovered, emerged from the darkness of the Sterkfontein caves. The young Australopithecus sediba whose fossils showed a fascinating mix of primitive and advanced features, was found in the Malapa cave. Each discovery added another piece to the puzzle of human evolution, another chapter in the story of how we became who we are. But Rising Star was different. Its secret was hidden deeper, protected by passages that seemed designed to keep out all but the most determined explorers. It's almost as if the cave itself was selective about who it would allow to discover what lay within. The narrowness of the passages meant that only people of a certain body type could reach the inner chambers. The complexity of the route meant that only experienced cavers would even attempt the journey. And the complete absence of any obvious fossils or formations in the accessible parts meant that there was little reason for anyone to push deeper into those challenging passages. The Earth has a way of revealing its secrets when the time is right, when the right people with the right tools and the right questions come along. For Rising Star, that time came in September 2013, though the story really begins a few weeks earlier with two recreational cavers named Stephen Tucker and Rick Hunter. They were experienced cavers, the kind who found joy in pushing into spaces that most people would find terrifying. They knew the caves of the cradle of humankind well, had explored many of them multiple times, always looking for passages that others might have missed, always wondering what might lie beyond the next squeeze, around the next corner, down the next drop. On that particular day, they entered Rising Star with no particular expectations. They navigated the familiar passages, squeezed through the narrow sections that had stopped so many others, and found themselves in a chamber about 30 meters below the surface. This chamber had been reached before, mapped even, but Tucker and Hunter noticed something that others had missed, or perhaps ignored. A narrow, jagged crack in the floor, barely wide enough for a person to fit through. It was the kind of opening that most cavers would glance at and dismiss. Too narrow, too dangerous, leading nowhere worth the risk. But Tucker and Hunter were not most cavers. They had that particular combination of curiosity and carefully managed recklessness that leads to discoveries. Tucker went first, squeezing into the crack, his headlamp illuminating only a few feet of a rock ahead of him. The passage dropped almost vertically, a chute of limestone that seemed to go down forever. He had to chimney down, using his back against one wall and his feet against the other, controlling his descent with pressure and friction. One slip, one moment of lost control, and he would fall into the unknown darkness below. The chute continued for 12 meters, a vertical maze of rock that required careful navigation. At times, it narrowed so much that Tucker had to exhale completely just to fit through, his chest compressed by the stone around him. At other times, it widened enough that he had to stretch to maintain contact with both walls, the void below always present, always waiting. His headlamp illuminated only small sections of rock at a time, leaving the rest in darkness. He couldn't see where he was going, only where he was. Finally, after what felt like hours but was probably only minutes, Tucker's feet found solid ground. He had reached the bottom of the chute. He stood in a small chamber, his headlamp sweeping across the space, revealing walls of flowstone and formations that glittered in the artificial light. But it wasn't the geological features that caught his attention. It was what lay on the floor. Bones. Not just a few scattered remains, but bones everywhere. The floor of the chamber was literally carpeted with them. In the beam of his headlamp, Tucker could see skulls, jawbones, ribs, vertebrae, long bones from arms and legs, all lying on the surface of the cave floor as if they had been carefully placed there. They weren't embedded in rock or covered by sediment. They were just lying there, waiting. Tucker called up to Hunter, his voice echoing strangely in the narrow chute. Hunter made the descent, and together they stood in what would later be named the Dinaledi chamber, the Chamber of Stars, named for the beautiful formations on the ceiling that sparkled like stars in their headlamps. They knew immediately that they had found something extraordinary. These weren't the bones of modern animals. They had the look of fossils, mineralized and ancient. And there were so many of them, more than either caver had ever seen in one place. But what struck them most was the condition of the bones. In most fossil sites, bones are scattered, broken, mixed with the remains of other animals. Predators leave tooth marks. Scavengers scatter remains. Water moves things around. Time and geology compress and distort. But these bones seemed almost pristine, as if they had been gently placed here and left undisturbed for millennia. There were no signs of predator damage, no tooth marks from hyenas or big cats. There were no other animal bones mixed in, just these remains of what looked like a single species. Tucker and Hunter took photographs, careful not to disturb anything. They understood the significance of what they had found, even if they couldn't fully comprehend its implications. They made the difficult climb back up the chute, squeezed back through the Superman crawl and the other narrow passages, and emerged into the South African sunshine with evidence of something that would shake the foundations of paleoanthropology. The photographs found their way to Lee Berger, a paleoanthropologist at the University of the Witwatersrand in Johannesburg. Berger was no stranger to significant discoveries. He had found Australopithecus sediba in 2008, a discovery that had made headlines around the world, but when he saw the images from the Dinaledi chamber, he knew this was something different, something potentially revolutionary. The sheer number of fossils, their apparent condition, and their location deep within this almost inaccessible cave suggested a mystery that went beyond simple fossil preservation. Berger faced an immediate problem. He needed to excavate these fossils properly, with scientific rigor and careful documentation. But the passage to the chamber was so narrow that he himself couldn't fit through it. Most experienced excavators couldn't fit through it. The standard approach to fossil excavation, bringing in a team of specialists with their equipment and expertise, was impossible. The cave had protected its secret for hundreds of thousands of years, and it wasn't going to give it up easily. So Berger did something unprecedented in paleoanthropology. He put out a call on social media for what he termed underground astronauts, skinny scientists who could fit through the narrow passages and had the skills necessary to excavate fossils properly. The requirements were specific and daunting. Candidates needed to have a background in paleontology or archaeology. They needed to be experienced cavers comfortable in extremely tight spaces. They needed to be small enough to fit through an 18-centimeter gap. And they needed to be able to work carefully and scientifically in challenging conditions. The response was remarkable. Within days, Berger had received applications from around the world. After a selection process that tested both physical capability and scientific competence, he assembled a team of 6 underground astronauts, all women as it turned out, who had the unique combination of skills, size and courage required for the job. There was Marina Elliott, a Canadian biological anthropologist who had worked on archaeological sites around the world. Becca Pichotto, an American archaeologist who specialized in careful excavation techniques. Hannah Morris, an American archaeologist with experience in challenging field conditions. Alia Gurtov, an American anthropologist studying human evolution. Lindsay Eves, a South African archaeologist who knew the local caves well. And Hélène Feuer-Riegel, an Australian archaeologist who had worked on sites across multiple continents. These 6 women would become the primary excavators of one of the most significant fossil discoveries in human history. But first, they had to get to the chamber. Even for experienced cavers, the journey to the Dinaledi chamber was daunting. They had to navigate not just the narrow passages, but do so while carrying excavation equipment, cameras, and lights. Every tool, every piece of equipment had to be small enough to fit through the narrowest points. Nothing could be rigid longer than the width of the passages. Everything had to be carefully planned. The excavation setup was unlike anything seen before in paleoanthropology. A command center was established at the surface, connected to the chamber by over 1 kilometer of cable. Cameras were installed in the Dinaledi chamber, allowing Berger and other scientists who couldn't fit through the passages to watch the excavation in real time. They could direct the underground astronauts, point out fossils of particular interest, and ensure that proper scientific protocols were followed. It was like a space mission, with mission control on the surface and astronauts in the deep, dark unknown below. The first descent of the underground astronauts into the Dinaledi chamber was a moment of profound significance. As Marina Elliott later described it, dropping into the chamber for the first time was like entering a sacred space. The bones were everywhere, so many that it was difficult to move without stepping near them. In some places, they were layered on top of each other, suggesting that bodies had been placed here over an extended period. The preservation was extraordinary. Delicate bones that usually don't survive fossilization, like the tiny bones of the inner ear, were intact. The excavation began with careful mapping. Every bone, every fragment, every piece of evidence had to be documented in its exact position before being removed. The underground astronauts worked in shifts, spending hours at a time in the chamber, carefully exposing fossils with brushes and small tools, photographing everything, taking measurements, making notes. The work was physically demanding, not just because of the careful excavation, but because of the journey to and from the chamber. Each day began and ended with navigating those challenging passages, a commute unlike any other in science. As the excavation progressed, the mystery deepened. The sheer number of individuals represented by the bones was staggering. There were infants, children, teenagers, adults, and elderly individuals. Both males and females were present. It wasn't just one or two individuals who had somehow ended up in this chamber, but at least 15 different people, though the number would eventually grow as more bones were discovered and analysed. This wasn't a single event, a family that had gotten trapped, or a group that had died together. The geological evidence suggested that these bodies had accumulated over time, perhaps over centuries or even millennia. But how did they get here? The journey to the chamber was difficult enough for living, experienced cavers with modern equipment and lights. How did ancient bodies end up in a chamber that required navigating a 12-meter vertical chute? There were no other entrances to the chamber, no evidence that the cave configuration had been significantly different in the past. The bodies couldn't have been washed in by water. There were no signs of water transport on the bones or in the sediment. They couldn't have been dragged in by predators. There were no tooth marks, no signs of carnivore activity, and no other animal bones mixed with the hominin remains. The most logical explanation seemed impossible, that these bodies had been deliberately placed here. But that would mean that someone or something had carried them through those narrow passages, down that vertical chute, in complete darkness, and carefully placed them in this chamber. It would mean that whoever did this could navigate complex cave systems, possibly had some form of light, and most remarkably had some reason for placing dead bodies in this incredibly difficult-to-reach location. As weeks turned into months, the underground astronauts continued their careful work. They developed a rhythm, a routine of descent, excavation, and ascent. The chamber became familiar to them, each section known and mapped. They gave names to particularly challenging parts of the excavation, created systems for managing the thousands of fragments they were recovering. The command center on the surface buzzed with activity as scientists analyzed the footage, directed the excavation, and began to piece together what these fossils were telling them. The bones themselves were a puzzle. They weren't like anything the scientists had seen before. Some features were remarkably human-like. The hands, for instance, had proportions very similar to modern humans, with a thumb and fingers that suggested a capability for precise manipulation. The feet were clearly adapted for walking upright, with a big toe in line with the other toes, not opposable like in apes. The teeth were small, more like human teeth than the large teeth of earlier hominins, but other features were decidedly primitive. The shoulders were configured for climbing, more like an ape than a human. The fingers were curved, suggesting a creature that still spent time in trees. The hips were flared in a way that hadn't been seen in human ancestors for millions of years. And most striking of all, the skull was tiny, with a brain case that could only have held a brain about the size of an orange, roughly a third the size of a modern human brain. This mosaic of features didn't fit neatly into any existing category. It wasn't a direct human ancestor, at least not an immediate one. It wasn't a known species of early hominin. It was something new, something that had existed alongside other hominin species but had never been found before. The team was looking at a ghost lineage, a branch of the human family tree that had been completely unknown to science. The excavation in the Dinaledi chamber continued for weeks, with the underground astronauts removing more than 1,500 fossil elements. It was one of the richest fossil sites ever discovered, and certainly the richest single accumulation of hominin fossils in Africa. Every part of the skeleton was represented, allowing scientists to reconstruct not just fragments of this creature, but entire individuals. They could see how the bones fit together, how the joints worked, how this creature would have moved and lived. But the central mystery remained. How did all these individuals end up in this chamber? The evidence increasingly pointed to deliberate disposal, but that raised even more questions. If these creatures with their tiny brains were deliberately placing their dead in this chamber, it suggested a level of behavior previously thought to be unique to humans and our immediate ancestors. It suggested planning, cooperation, possibly even some form of ritual or symbolic thinking. The idea was controversial to say the least. Mortuary behavior, the deliberate treatment of the dead, has long been considered a hallmark of humanity. It requires an understanding of death, a recognition that the dead are different from the living, and usually some concept of what should be done with bodies. It often involves ritual, symbolism, and shared cultural practices. To suggest that a small-brained hominin might have engaged in such behavior challenged fundamental assumptions about the relationship between brain size and cognitive complexity. As the excavation neared its end, at least for this phase, the team had recovered enough material to keep scientists busy for years. The fossils needed to be carefully cleaned, analysed, compared to other hominin fossils, and subjected to various dating techniques. The sediments needed to be studied to understand the geological history of the chamber. Every piece of evidence needed to be examined and re-examined. The announcement of the discovery, when it came in 2015, sent shockwaves through the scientific community. Lieberger and his team introduced the world to Homo naledi, named after the chamber where it was found. Naledi means star in Sotho, a reference to the Dinaledi chamber, the chamber of stars. The name was fitting for a creature that had remained hidden in darkness for so long, only to emerge into the light of scientific scrutiny like a star appearing in the night sky. The scientific papers describing Homo naledi were remarkable not just for what they revealed, but for how they were produced. In an unprecedented move, Berger invited scientists from around the world to participate in the analysis, creating a workshop where dozens of experts examined the fossils together. It was a collaborative effort unlike anything seen before in paleoanthropology, a field often marked by competition and secrecy. The fossils were made available for study, 3D scans were shared freely, and the scientific process was opened up in a way that reflected the extraordinary nature of the discovery. The anatomy of Homo naledi, as revealed by these studies, was even more puzzling than initially thought. The hands were capable of both powerful gripping and precise manipulation. The shoulder and arms suggested climbing abilities, but the legs and feet were fully adapted for long-distance walking. The teeth suggested a diet that included tough, hard foods, but also softer items. Every part of the skeleton told a story of a creature that lived in multiple worlds, comfortable on the ground but capable in the trees, with hands that could make and use tools but a brain that seemed too small for complex thought. Dating the fossils proved challenging. The Dinaledi chamber had unusual geology that made standard dating techniques difficult. The bones weren't embedded in flowstone that could be directly dated, and the sediments had a complex history. Initial attempts to date the site were inconclusive, leading to speculation that Homo naledi could be anywhere from 3 million to 100,000 years old. The uncertainty was frustrating but also exciting. If Homo naledi was very old, it might represent an early experiment in the hominin form. If it was young, it meant that a small-brained hominin had survived much longer than anyone thought possible. Meanwhile, the excavations continued. The Rising Star cave system was more extensively explored, and in 2017 another chamber was discovered, the Naledi chamber, which contained more Homo naledi fossils, including a remarkably complete skeleton nicknamed Neo. The Naledi chamber was even more difficult to reach than the Dinaledi chamber, requiring navigation through passages that were at times barely navigable, even for the smallest cavers. Yet it too contained deliberately placed bodies, reinforcing the hypothesis that Homo naledi was engaging in some form of mortuary behaviour. The dating breakthrough came in 2017, when a combination of techniques finally provided an age for the Homo naledi fossils. The results were stunning. The bones were between 236,000 and 335,000 years old. This was far younger than most scientists had expected. It meant that Homo naledi had existed at the same time as early Homo sapiens. While our ancestors were developing the complex behaviours that would eventually lead to art, language and civilization, Homo naledi was living alongside them, following its own evolutionary path, developing its own behaviours, possibly even its own culture. This date transformed our understanding of human evolution in Africa. For years, the story had been relatively simple. Small-brained, primitive hominins gave way to larger-brained, more advanced species, eventually leading to Homo sapiens. But Homo naledi showed that evolution wasn't a ladder with each species replacing the previous one. It was more like a braided stream, with multiple species existing simultaneously, each adapted to its own niche, each following its own path. The implications were profound. If Homo naledi was placing its dead in caves 300,000 years ago, it wasn't alone in Africa. Early Homo sapiens were there too, along with possibly other hominin species we haven't discovered yet. Did they ever meet? Did they interact? Did they compete for resources or avoid each other? The fossil record is silent on these questions, but the possibilities fire the imagination. As more fossils were studied, more details about Homo naledi's life emerged. The teeth showed patterns of wear consistent with a varied diet. Some individuals showed signs of dental disease, suggesting they lived long enough to experience the kinds of health problems that come with age. The bones showed no signs of chronic malnutrition, suggesting that whatever environment they lived in, they were successful at finding food. Some bones showed healed injuries, indicating that individuals survived trauma that would have been fatal without some form of care from others. The hand bones were particularly revealing. They showed areas of muscle attachment that suggested powerful gripping, the kind needed for climbing. But they also had the proportions necessary for precision grip, the ability to hold objects between the thumb and fingers with fine control. This combination suggested a creature that could make and use tools, even if no tools have been found directly associated with the fossils. The curve of the fingers, however, suggested that climbing was still an important part of their lifestyle. The foot bones told their own story. The big toe was fully in line with the other toes, not opposable like in apes. This meant Homo naledi was committed to bipedal locomotion. It couldn't grasp branches with its feet. The arch of the foot was well developed, providing the spring necessary for efficient walking and possibly running. Yet the toes were slightly curved, more so than in modern humans, suggesting some remaining adaptation to climbing. It was as if Homo naledi was caught between two worlds, fully capable on the ground but not entirely divorced from the trees. The skull and brain of Homo naledi presented the biggest puzzle. With a cranial capacity of only about 500 cubic centimeters, the brain was tiny by human standards, closer in size to a chimpanzee's than to ours. Yet this small brain was housed in a skull with some surprisingly modern features. The shape of the skull was more globular than in earlier hominins, a characteristic associated with modern humans. The teeth were small and arranged in a parabolic arch, like ours, rather than the U-shaped arch of apes? How could a creature with such a small brain engage in complex behavior like deliberate body disposal? This question challenged one of the fundamental assumptions of paleoanthropology, that behavioral complexity is directly related to brain size. For decades, scientists had used brain size as a proxy for cognitive ability, assuming that bigger brains meant more complex behavior. Homo naledi suggested that this relationship might not be so simple. Some scientists proposed that it wasn't the size of the brain that mattered, but its organization. Perhaps Homo naledi's small brain was wired differently, more efficiently, allowing for complex behavior despite its size. Others suggested that the behavior might not be as complex as it appeared. Perhaps the bodies ended up in the chambers through some natural process we don't yet understand. The debate continues, with each new piece of evidence adding to the discussion, but not definitively resolving it. The excavations in Rising Star have now recovered fossils from at least 27 individuals, making it one of the most complete pictures we have of any extinct hominin species. We know more about Homo naledi's anatomy than we do about many species that have been known for decades. Yet in many ways, the mystery has only deepened. The more we learn about Homo naledi, the more questions arise about its life, its behavior, and its place in the human story. The chamber itself has become a character in this story. The Dinaledi chamber, with its carpet of bones and its glittering ceiling, feels almost sacred, a place where the boundary between life and death was marked hundreds of thousands of years ago. The difficulty of reaching it only adds to its mystique. It's as if Homo naledi chose the most remote, most protected place possible for its dead, a place where they would remain undisturbed for millennia. The underground astronauts who excavated the chamber speak of it with a kind of reverence. They describe the profound silence, broken only by their own breathing and the soft scratch of their tools. They talk about the weight of responsibility they felt, knowing they were the first people in perhaps 300,000 years to see these remains. They describe moments of connection across the vast gulf of time, looking at a hand bone and realizing it was so much like their own, yet belonged to a creature separated from them by thousands of generations. The sediments in the chamber have their own story to tell. They accumulated slowly, grain by grain, over thousands of years. They contain microscopic evidence of the environment at the time the bones were deposited, pollen grains that suggest what plants were growing above, minerals that indicate the chemistry of the water that occasionally dripped into the chamber, tiny fragments of charcoal that might indicate fire use, though this remains highly controversial. One of the most intriguing aspects of the Dinaledi chamber is what it doesn't contain. There are no stone tools, no ornaments, no obvious grave goods. If this was deliberate burial, it was remarkably simple. Just bodies placed in a chamber. There are no signs of violence on the bones, no evidence that these individuals died traumatically. They seem to have died naturally and then been carried into the chamber. This simplicity is itself meaningful, suggesting perhaps a basic recognition of death without the elaborate rituals that characterize later human burial practices. The discovery of Homo naledi has forced us to reconsider what makes us human. If a small-brained hominin could engage in deliberate body disposal, what other behaviors might it have been capable of? Could it have had some form of language, some kind of social structure that included care for the dead? Some concept of identity that made it important to treat bodies in a particular way? These questions push at the boundaries of what we can know from fossils, entering the realm of speculation, but they are questions that the evidence demands we ask. As we think about Homo naledi navigating those dark passages to place its dead, we're confronted with the possibility that the human story is far more complex than we imagined. The traditional narrative of human evolution, with its steady progression from primitive to advanced, from small-brained to large-brained, from simple behavior to complex culture, doesn't account for creatures like Homo naledi. It existed outside this narrative, following its own path, developing its own solutions to the challenges of survival. The darkness of the cave takes on new meaning when we consider that Homo naledi was navigating it intentionally. Did they have some form of fire to light their way? The evidence for this is controversial but intriguing. There are fragments of charcoal in the sediments, burn marks on some bones that might indicate controlled fire use. If Homo naledi had fire, it would revolutionize our understanding of when this crucial technology was mastered. But the evidence is far from conclusive, and many scientists remain skeptical. Even without fire, the navigation of these passages in darkness would have required remarkable spatial memory and possibly cooperation. Individuals would have had to work together to move bodies through the narrow passages down the vertical chute. They would have had to remember the route in complete darkness, using touch and perhaps sound to guide them. This suggests cognitive abilities that go beyond what we might expect from a creature with such a small brain. The accumulation of bodies over time suggests that this wasn't a one-time event but a tradition, passed down through generations. Somehow, the knowledge of this special place, this chamber deep in the earth, was maintained and transmitted. Young Homo naledi would have had to learn about it, possibly be shown the way, understand its significance. This implies cultural transmission, the passing of information through learning rather than instinct, another behavior we associate with humanity. Part 2. The Shadow of Another Mind. The world beyond the rising star cave system, the world where Homo naledi lived and died 300,000 years ago, was a place of extraordinary richness and danger. Picture, if you will, the landscape of Pleistocene South Africa, a realm that would seem both familiar and utterly alien to modern eyes. This was not the Africa of today, with its carefully managed game reserves and well-mapped territories. This was a wilderness beyond imagination, where the boundaries between species were still being written, where evolution was conducting its grand experiments in real time, and where multiple types of humans walked the same paths, perhaps passing each other in the gathering dusk without knowing they represented different branches of the family tree. The climate was different then, oscillating between periods of warmth and cold, wetness and drought, in cycles that lasted thousands of years. During the time of Homo naledi, South Africa was experiencing one of these fluctuations, creating a mosaic of environments that changed with the seasons and the centuries. There were vast grasslands that stretched to the horizon, punctuated by islands of forest that clung to riverbanks and sheltered valleys. These forests were not the tropical rainforests of Central Africa, but temperate woodlands filled with yellowwood trees and wild olives, their canopies creating cathedral-like spaces where light filtered through in golden streams. The grasslands themselves were not uniform but varied in character depending on rainfall and soil. In some areas, they were true savannas, dotted with acacia trees whose umbrella-shaped crowns provided shade for the creatures below. In others, they were more like prairies, seas of grass that rippled in the wind like waves on an ocean of green and gold. These grasslands supported vast herds of animals, migrations that would dwarf anything we see today. Imagine hundreds of thousands of antelope moving across the landscape in response to the rains, their hoofbeats creating a thunder that could be heard for miles, their movements stirring up clouds of dust that painted the sunset in shades of orange and red. Among these herds moved creatures that no longer exist, victims of the extinctions that would come later. There were giant buffalo, Pelorovis, with horn spans that could reach 2 meters, massive animals that stood as tall as a modern elephant at the shoulder. These were not the Cape buffalo we know today, but something altogether more formidable. Creatures that even the biggest predators approached with caution. There were various species of giant hartebeest, antelope that combined speed with size in ways that seem impossible now. There were elephants, but not just the African elephants we know. There were also extinct species with different tusk arrangements, different body proportions, each adapted to slightly different niches in this complex ecosystem. The predators of this world were equally magnificent and terrifying. The lions were there, but they were different from modern lions, some possibly larger, others with different hunting strategies adapted to the megafauna they pursued. There were saber-toothed cats, Dinophilis and Meganterion, specialized killers whose elongated canines were perfectly designed for delivering a killing bite to the throat of their prey. These cats were ambush predators, waiting in the margins between forest and grassland for unwary animals to pass. Their presence would have been a constant threat to any hominin moving through the landscape. There were hyenas, but not just the spotted and brown hyenas we know today. There were also giant hyenas, Pachyrhinocuta, bone-crushing specialists that could splinter the femur of an elephant with their massive jaws. These were not the opportunistic scavengers of popular imagination, but active predators capable of bringing down large prey. Their dens, filled with the accumulated bones of countless meals, would have been places of horror for any hominin unlucky enough to stumble upon them. Into this world of giants and predators, Homo naledi carved out its existence. With its small stature, probably standing no more than 1.5 meters tall, and its modest brain, it might seem ill-equipped for survival in such a dangerous environment. Yet the fossil evidence tells us it thrived for hundreds of thousands of years, suggesting it had found successful strategies for navigating this complex and dangerous world. The anatomy of Homo naledi suggests it was exploiting a unique niche, one that combined terrestrial and arboreal lifestyles in ways that other hominins of the time did not. During the day, it might have foraged on the ground, using its human-like feet to walk efficiently across the grasslands and through the woodlands. Its hands, with their mix of primitive and derived features, would have been perfect for gathering a variety of foods, fruits from trees, tubers from the ground, perhaps insects from under bark or in rotting logs. The curved fingers suggest it could still climb when necessary, perhaps to escape predators or to reach foods that other terrestrial animals couldn't access. As evening approached and the predators became more active, Homo naledi might have retreated to the trees or to rocky outcrops where its climbing abilities gave it an advantage. The shoulders and arms, with their ape-like configuration, would have allowed it to pull itself up quickly and efficiently. In the trees, it would have been safe from most ground predators, though not from leopards, which were as comfortable in the branches as on the ground. The night sounds of Pleistocene Africa, the roar of lions, the whooping of hyenas, the screams of prey animals meeting their end, would have been the soundtrack to Homo naledi's existence. But Homo naledi was not alone in this world. This is perhaps the most extraordinary aspect of its story. Living at the same time, in the same general region, were early members of our own species, Homo sapiens. The oldest fossils of our species from Africa date to around 300,000 years ago, exactly the same time period as the Homo naledi fossils from Rising Star. These early Homo sapiens were not yet the fully modern humans we are today, but they were on that trajectory, with larger brains, more sophisticated tool use, and presumably more complex social behaviours. The coexistence of these two species of human raises profound questions. Did they ever encounter each other? The fossil record is silent on direct interactions, but given that they lived in the same region for potentially thousands of years, it seems almost impossible that they never met. What would such a meeting have been like? Would they have recognized each other as somehow similar, both walking upright, both using their hands to manipulate objects, both living in social groups? Or would the differences have been more striking than the similarities? Early Homo sapiens had brains nearly 3 times the size of Homo naledi's. They were making sophisticated stone tools, including prepared core technology that required planning and foresight. They were probably using fire regularly, not just for warmth and protection, but for cooking, fundamentally changing their relationship with food. They might have had some form of language, though this remains debated. They were beginning to show signs of symbolic behaviour, though full-blown art and ornament use wouldn't appear in the archaeological record for another 100,000 years or more. Homo naledi, with its small brain, presents a different picture. The absence of stone tools directly associated with Homo naledi fossils is puzzling. Its hands were certainly capable of making and using tools, but if it did so, it might have used materials that don't preserve well like wood or plant fibers, or perhaps its tool use was so different from what we expect that we simply haven't recognized it in the archaeological record. The possibility that it was using fire, suggested by some controversial evidence from the Rising Star caves, would indicate a level of technological sophistication that seems at odds with its small brain. The two species might have occupied different ecological niches, reducing direct competition. Homo sapiens, with its larger body size and more advanced technology, might have been better adapted to open environments, hunting larger game and processing a wider variety of foods. Homo naledi, smaller and retaining climbing abilities, might have focused on forest edges and rocky areas where its unique combination of features gave it an advantage. They might have been active at different times of day, or focused on different food sources, allowing them to coexist without direct conflict. But coexistence doesn't mean ignorance of each other's presence. Both species would have been aware of the other through tracks, abandoned campsites, the remains of meals, perhaps distant sightings. For Homo sapiens, encountering Homo naledi might have been unsettling, seeing creatures so similar to themselves yet clearly different. Did they recognize them as relatives, however distant? Did they see them as competitors, as curiosities, as something to be avoided or possibly even hunted? We can only speculate, but the possibilities are haunting. For Homo naledi, the presence of Homo sapiens might have been equally significant. Did they observe these larger-brained relatives from a distance, perhaps learning from them, copying their behaviors? Did they avoid areas where Homo sapiens was active, retreating to more marginal environments? Or did they sometimes interact peacefully, perhaps even exchanging materials or information in some rudimentary way? The fossil record provides no answers, only questions that tug at our imagination. The landscape itself was shared not just by these two human species, but possibly by others as well. This was a time of hominin diversity in Africa that we're only beginning to understand. There are fossils from this period that don't fit neatly into any species category, suggesting that the human family tree was bushier than we've imagined. Each of these species or populations would have had its own adaptations, its own strategies for survival, its own place in the ecosystem. The animals of this world would have responded differently to these various human species. Predators would have learned their patterns, their weaknesses, their strengths. Prey animals would have developed avoidance strategies specific to each type of human hunter. The ecosystem was a complex web of relationships, with each species influencing the others in ways both subtle and profound. Homo naledi was part of this web, both predator and prey, competitor and cooperator, shaping and being shaped by the world around it. The evidence from the Rising Star caves takes on new significance when we consider this broader context. The deliberate placement of dead in the Dinaledi and Lasidi chambers wasn't happening in isolation, but in a world where other human species might have been engaging in their own mortuary practices. Early Homo sapiens from this period show some evidence of special treatment of the dead, though nothing as elaborate as the later burial practices that would develop. Did Homo naledi develop its cave disposal tradition independently, or was it influenced by observing other species? Did the practice serve to mark territory, to establish a claim to a particular area? Was it purely practical, removing bodies from living spaces to avoid disease and predators? Or did it have deeper meaning? The journey into the dark chambers of Rising Star takes on new dimensions when we imagine it happening in this rich, dangerous world. After a life spent navigating the challenges of Pleistocene Africa, avoiding predators, finding food, raising young, an individual Homo naledi would die. And then, remarkably, instead of being left where they fell or consumed by scavengers, their body would be carried by their companions into the darkness of the cave. The contrast between the bright, dangerous, vibrant world above and the silent, eternal darkness below could not be more stark. We return now to those chambers to examine more closely the most controversial and potentially revolutionary discoveries from Rising Star. In 2022, Lee Berger and his team made announcements that would once again shake the foundations of our understanding of human evolution. They presented evidence that Homo naledi might not have just been disposing of its dead in these chambers, but might have been using fire to light its way and possibly even creating art on the cave walls. These claims, if verified, would fundamentally change our understanding of the relationship between brain size and cognitive complexity. The evidence for fire use comes from several sources. Throughout the cave system, the team found areas of blackened sediment and ceiling surfaces that appeared to be soot deposits. There were fragments of charcoal in the sediments of the chambers, and some bones showed signs of burning. Most intriguingly, there were what appeared to be hearth-like structures, areas where fires might have been repeatedly built. The distribution of these potential fire traces wasn't random, but seemed to follow the routes through the cave system, as if torches or fires had been used to navigate the passages. Fire use by Homo naledi would be extraordinary for several reasons. First, the controlled use of fire has long been considered a hallmark of advanced cognition. It requires not just the ability to maintain fire, but to transport it, to understand its properties, to plan for its use. Second, the use of fire in the deep caves would have been essential for the kind of mortuary behaviour suggested by the fossil accumulations. Without light, navigating those passages with a body would have been virtually impossible. Third, fire use would suggest a level of technological sophistication that seems at odds with Homo naledi's small brain size. The skeptics, and there are many, point out that the evidence for fire use is circumstantial. Charcoal can enter caves through various natural processes. Blackened surfaces might be the result of manganese deposits or other minerals, not soot. The apparent hearths could be natural accumulations of material. Without more definitive evidence, such as clearly defined fireplaces with ash layers and heat-altered sediments, the claim of fire use remains controversial. The debate continues, with each side presenting evidence and counter-evidence, the scientific process playing out in real time. Even more controversial is the evidence for what might be symbolic behaviour or even art. On the walls of the caves, particularly near the entrances to the chambers containing fossils, the team found engravings. These weren't natural formations, but deliberate marks made by scraping or carving into the soft limestone. The most striking of these is a series of cross-hatched lines, forming a rough hashtag-like pattern. The lines are deeply incised, clearly intentional, and would have required significant effort to create. If these engravings were made by Homo naledi, they would represent the earliest known symbolic markings in the hominin record, predating the earliest known human art by hundreds of thousands of years. They would suggest that even with a brain the size of an orange, Homo naledi was capable of symbolic thought, of creating marks that had meaning beyond their physical form. This would revolutionize our understanding of cognitive evolution, suggesting that symbolic behavior isn't dependent on large brain size but might emerge from different organizational patterns or social structures. The location of these engravings is significant. They're found near the entrances to the mortuary chambers, possibly serving as markers or symbols related to the treatment of the dead. Were they territorial markers, indicating that this cave belonged to a particular group? Were they symbolic representations related to death or the afterlife? Were they simply the result of repeated tool sharpening or some other utilitarian behavior that happened to leave marks? Each interpretation has profound implications for our understanding of Homo naledi's cognitive abilities. The scientific community has responded to these claims with a mixture of excitement and skepticism. Some researchers argue that extraordinary claims require extraordinary evidence, and that the current evidence, while intriguing, isn't sufficient to support such revolutionary conclusions. Others point out that we've consistently underestimated the capabilities of extinct hominins, always assuming that complex behaviours required large brains and modern human-like cognition. Perhaps Homo naledi is teaching us that there are multiple paths to behavioural complexity. The engravings, if they are indeed symbolic markings, raise questions about communication and social learning in Homo naledi. Symbols only have meaning if that meaning is shared, if there's agreement within a group about what a particular mark represents. This would imply some form of communication system, perhaps not language as we know it, but some way of transmitting meaning and maintaining cultural traditions. The fact that the mortuary behaviour appears to have continued for thousands of years suggests strong cultural transmission, the passing of knowledge and practices from generation to generation. The small brain of Homo naledi forces us to reconsider our assumptions about intelligence and consciousness. We've long used brain size as a proxy for cognitive ability, assuming that bigger brains meant more complex behaviour, richer inner lives, greater awareness. But what if consciousness and intelligence aren't simply about quantity of neural tissue, but about its organisation? What if Homo naledi's small brain was wired in ways that allowed for complex behaviours despite its size? What if there are forms of intelligence and awareness that we haven't imagined because they don't fit our human-centred view of cognition? Consider the possibility that Homo naledi had a rich inner life, awareness of self and others, emotional connections and social bonds, all housed in a brain a third the size of ours. It challenges our sense of human uniqueness, suggesting that the qualities we consider most essentially human might not be unique to us at all. If Homo naledi was capable of symbolic thought, of honouring its dead, of creating meaning through marks on stone, then consciousness and culture might be more widespread in nature than we've assumed. The implications extend beyond Homo naledi to our understanding of human evolution more broadly. If multiple species of humans coexisted in Africa 300,000 years ago, each with its own adaptations and possibly its own forms of culture, then the emergence of modern human behaviour wasn't a singular event, but a complex process involving multiple experiments in being human. Some of these experiments, like Homo naledi, ultimately went extinct, but they might have contributed to the broader patterns of cultural and biological evolution that eventually produced us. The question of what happened to Homo naledi is as mysterious as its life. The species seems to have survived for hundreds of thousands of years, successfully adapting to its environment and maintaining its cultural traditions. Then, sometime after 250,000 years ago, it disappears from the fossil record. Was it outcompeted by Homo sapiens as our ancestors developed more sophisticated technology and expanded into new environments? Did climate change alter its habitat in ways it couldn't adapt to? Did disease, possibly transmitted from other hominin species, play a role? Or did Homo naledi genes get absorbed into the expanding Homo sapiens population through interbreeding, living on in us in ways we haven't yet detected? The disappearance of Homo naledi is part of a larger pattern of hominin extinctions that occurred over the past few 100,000 years. One by one, the various human species that once populated Africa and Eurasia went extinct, leaving Homo sapiens as the sole surviving member of the genus Homo. Each extinction represents the loss of a unique experiment in being human, a different solution to the challenges of survival, a different form of consciousness and culture. The world became less diverse, more uniform as our species spread across the globe. But perhaps Homo naledi's legacy lives on in ways beyond genetics. The caves of Rising Star, with their carefully placed bodies, stand as monuments to a species that cared for its dead, that created traditions lasting millennia, that possibly made the first symbolic marks on stone. These chambers are like libraries, preserving not just bones but behaviours, not just fossils but culture. They remind us that we were not alone in developing the capacities we consider most human. The ongoing research at Rising Star continues to reveal new aspects of Homo naledi's story. Each field season brings new discoveries, new fossils, new evidence that adds to or challenges our understanding. The cave still holds secrets, passages yet unexplored, chambers yet undiscovered. Who knows what revelations await in the darkness? What other evidence of Homo naledi's life and culture remains to be found? The technology being applied to study Homo naledi is also advancing rapidly. New dating techniques provide more precise ages for the fossils. Advanced imaging allows scientists to study the internal structure of bones and teeth, revealing details about growth, development, and health. Genetic analysis, though challenging with such ancient fossils, might eventually reveal DNA sequences that could tell us about Homo naledi's relationships to other hominins and possibly about traits that don't preserve in bone. Virtual reconstructions allow scientists to study how Homo naledi moved, how its joints worked, how efficient its locomotion was. Computer models can simulate different scenarios for how bodies ended up in the chambers, testing whether natural processes could account for the accumulations or whether deliberate placement is the only explanation. Each technological advance opens new windows into the past, allowing us to see Homo naledi more clearly, even as it raises new questions about its life and behavior. The story of Homo naledi also has implications for the search for human origins in other parts of the world. If such a significant species could remain hidden until 2013, unknown to science despite leaving hundreds of fossils, what else might be out there? How many other branches of the human family tree remain undiscovered, their fossils lying in caves or buried in sediments, waiting for the right person to find them? The discovery of Homo naledi reminds us that we're still in the early stages of understanding human evolution, that there are more surprises waiting. The public fascination with Homo naledi reflects our deep interest in understanding our origins and our place in nature. The idea that we shared the world with other human species, that we were once just one of several experiments in humanity, captures the imagination. It makes us wonder about roads not taken, about alternative forms of human consciousness and culture that might have developed if history had unfolded differently. It also makes us reflect on our current uniqueness as the sole surviving human species and the responsibility that comes with that status. Educational programs have brought the story of Homo naledi to schools and museums around the world. Children learn about these ancient relatives, imagining what it would have been like to meet them, to see the world through their eyes. The small size of Homo naledi, not much taller than many children, makes it particularly relatable. The idea that they might have created art and honoured their dead makes them seem more human, bridging the vast gulf of time that separates us. The scientific debate over Homo naledi's capabilities has also become a teaching tool, showing how science works, how evidence is evaluated, how theories are tested and refined. Students learn that science isn't about absolute truth, but about the best explanation given current evidence, that new discoveries can overturn long-held beliefs, that mystery and uncertainty are not flaws but features of the scientific process. Homo naledi has become a case study in how we know what we know about the past. The ethical dimensions of studying Homo naledi have also emerged as important considerations. These were sentient beings, possibly with their own forms of culture and meaning-making. How should we treat their remains? What responsibilities do we have to tell their story accurately and respectfully? The decision to make the fossils widely available for study, to share data openly, reflects a commitment to transparency and collaboration that honours both the scientific process and the beings being studied. The caves themselves have become places of pilgrimage for those interested in human origins. Though the deep chambers remain accessible only to trained cavers and scientists, the site has become a symbol of the mysteries still hidden in the earth. The name Rising Star has taken on new meaning, representing not just the cave system, but the rise of new understanding, new questions, new ways of thinking about what it means to be human. As night falls over the cradle of humankind, as it has for millions of years, the caves return to darkness. But now we know that this darkness holds stories, that in chambers deep beneath the surface lie the remains of creatures that once looked up at the same stars we see, that face the same fundamental challenges of survival and meaning that we face. Homo naledi, the star person, emerged from this darkness to challenge our assumptions and expand our understanding of the human story. The research continues. with new expeditions planned, new technologies being applied, new questions being asked. Each discovery adds another piece to the puzzle, but like all good mysteries, each answer leads to new questions. How extensive was Homo naledi's range? Did it exist only in South Africa, or might its fossils be found elsewhere? What was the full extent of its behavioural repertoire? Did it have capabilities we haven't yet discovered? How did it perceive the world, and what can its story teach us about our own evolution and nature? The chambers of Rising Star continue to yield their secrets slowly, reluctantly, as if the Earth itself understands the magnitude of what it's revealing. Each fossil extracted, each piece of evidence analysed, adds to a story that becomes richer and more complex with each telling. The picture that emerges is not of a simple primitive creature, but of a being that, despite its small brain and mosaic anatomy, achieved something remarkable. It developed traditions, possibly created symbols, and found ways to honour its dead that speak to something deep and universal in the nature of consciousness and culture. As we contemplate Homo naledi's story, we're reminded that evolution is not a ladder leading inevitably to us, but a sprawling bush with many branches, each reaching toward its own version of success. Homo naledi represents one of these branches, a path that paralleled our own for hundreds of thousands of years, before ending for reasons we may never fully understand. Its existence enriches our understanding of what it means to be human by showing us that there were other ways of being almost human, other experiments in consciousness and culture that the universe tried before settling on us. The fossils in the Dinaledi chamber, lying in their bed of sediment, are more than just bones. They're messages from a species that found meaning in placing its dead in a special place, that possibly marked this place with symbols that might have used fire to light the darkness. They speak to us across 300,000 years, telling us that we were not alone in developing the capacities we consider most precious, that consciousness and culture might be more resilient, more diverse, more creative than we ever imagined.